Our next talk is Building Better Web APIs by HawkOwl. HawkOwl is best known for releasing the past 2 versions of Twisted, writing random software, and living in the absolute middle of nowhere for most of their lives. Their goal is to make developers' lives easier and, by extension, help them create better products. Ladies and gentlemen, HawkOwl.
Hello everyone, this is quite a crowd. Hello, I'm HawkOwl. This is my email and my Twitter, if you want to yell at me. My day job is working on retail software at a small company called Pycon-au. I do Django stuff there. In my free time, I am a Twisted core developer and release manager. So far I've released 2 versions, 13.2 and 14.0. And when I first started at Pycon-au, I was writing Django like Twisted, which there were whole patches to remove the camel case. So that was fun. I've compiled this talk from, I've been making a book almost, and I've been putting it all up here. So if you want to know anything about or elaborate, then up here probably has it. So I'm here to talk about building better web APIs, why we need them, how we can make them better, and how we can make them much easier to write. But since not everyone has a web API, some people will build products without them, I think I'll just go into just short what they are and what benefits they give us, both as developers and as businesses. Well, APIs are how applications basically talk. It's how they access things that aren't themselves through some standardized way. This means that you can have your common functionality, such as microservices, for example, and you can bundle them away and have them as nice, discrete parts with known interfaces. You can implement them once and access them anywhere, so which with web APIs, that anywhere can now be on the other side of the globe because it just talks through the internet. You can break open the silo of data stored in one location. So for example, if you're storing like weather data or something like that from the Bureau of Meteorology, you can use web APIs, or rather in this case FTP, to download that all down and use it anywhere else. So you can get data out a lot easier. You can also upload data, which is really good because you can have like crowdsourcing. So you can have people that do Yelp, they have ratings and all that, and that gets collated and processed in one location, and then you only need to go one location. You don't have to talk to 500,000 people to figure out where to eat. You can just go to a website. And because it's done in a machine talkable language, you can do it with just about anything. It doesn't have to come from humans. You can have, for example, climate control systems. You can have lots and lots of sensors everywhere, and they can point out where it's hotter, where you might have leaks. Microsoft did a thing where they saved a whole bunch of money just by figuring out where they were leaking stuff from their data centers. There's quite obviously a lot of applications for this, as most of you probably know. You can grab huge amounts of data, store it, process it, do whatever you want with it. You can expand out to EC2, do it all up there. It's brilliant. In fact, because of machines being able to do things like your little sensors and everything, people call it Web 3.0, the Internet of Things. That's dumb. It's more like the programmable internet. Nothing's changed. It's just that now we can sort of widen our reach of what we can access. We don't have to access it through a serial cable or anything like that. We can access it over the web. So here's some companies that do API things. Like lots of these companies, for example, Mailgun and Rackspace, you mainly use them through their APIs. So there are businesses which are basically just entirely APIs. Then you have companies like Google, which, for example, you have the Google Maps API, which is very popular, and Linode, which they mainly do servers, but they also have some APIs to do things with those servers. The best sort of APIs are the ones which you can do anything that you could do as a person. So that means that you can do interfaces that are fully rich that aren't your website. So you can have mobile clients that just talk to your regular API, and because it's so rich, it can do anything. And because you can do anything, For example, with Amazon, you can have machines doing it for you. You can have them detect that there's a lot of load and spin up EC2 instances and spawn more web servers without any human intervention because they can do everything that we can do. There's a whole bunch of benefits. Obviously, automation and crowdsourcing and a lot of business things that you can basically use that as competition. You can say, you can automate this. So since they're good, we need to implement them. The first thing you should do is think about who your users are. Who are we designing this for? It's good to design something for someone and not just write something out and be done, because then you end up with something that no one wants to use, and that's not good. If you design for the end user, the user at the end of it that is going to be using an app or a website or a device which talks to your API, you want to expose all the data that they might need. You want to make sure that you can provide encrypted endpoints, for example, using TLS everywhere, because security, especially these days, is absolutely paramount. And for the implementer, the person that writes the application or writes against your API, you want to make sure that you don't surprise them, that if you give them some docs, that they can sort of go along and they don't have to pay very much attention. It should just all make sense. You want to make it stable so that if a couple of years down the line, they don't have to rewrite everything. And you want to provide documentation so that there's not a massive learning curve, because that's, if you're doing something and there's a massive learning curve, we're developers, our attention spans are quite short. We'll just go and do something else. So as far as stability, the number one thing is versioning. You want to provide explicit versions. You don't want to have something that isn't namespaced and just change it whenever, because that will break applications. And just like the desktop, like Microsoft had a lot of these problems with Visual C++, where you can't drop them out because they're incompatible. So you need to namespace them. You need to be able to provide API pinning. So for example, you can say, I use version 1 of the API, and that's all I use. So you don't inadvertently push someone onto something that breaks and provide a bad user experience. There's a few ways of doing it. You can put it in the URI. For example, this example from Route 53 puts the date of the API right in there. Stripe uses a header. They update very frequently. I think they do it a couple times a month. And Heroku, they update less frequently, but they also use a header. They put it in the accept header. So there's a couple of different ways of doing it. Personally, I think the best way is putting it in the URI. It makes a lot of sense. You don't have to fiddle with headers, and it just sort of makes it a lot more obvious what version you're talking to. There's two ways of doing it, well, there's multiple ways of doing this, but these are the two ones. Like you have an entire different server that does it, or an entire different virtual host that does it, or you put it all under the same one. I reckon all under the same one is better. There's no reason why in modern web frameworks you can't have multiple implementations side by side. As Tim Berners-Lee said back in 1998, cool URIs don't change. I think that should go one step further. When you're providing structured data, I think that the structure should not change either. For human readable documents, that sort of goes that the content shouldn't change. But for machines, content is also how it is formatted. So if you make sure that that doesn't change over the lifetime, then that works. There was a question when I did a dress rehearsal of this talk that if you've got version 1 of a resource and version 2 of a resource, aren't they technically the same thing? Well, yes, but I think that breaking it enough for this is worth it, because different versions will have different responses and different formatting and possibly a different resource layout. You might have something that's called like cakes, and then it might be changed to some other name. And if you've got them all side by side, it's a bit more confusing. While if you have them all namespace, you can say, okay, cakes is a 404. We don't have to check whether it's an old version. There's also been a lot of things about layout, especially recently how there's been all the REST stuff. I'll get to that later, but mainly layout. We want to lay it out like there's resources, like there's bundles of data, not just functions. You don't want to have like that and pass in an ID, you can put that straight in the URI. And that also makes a lot of sense because it is cake 1, for example, in this example. It's not a function. You can then have, this is a common thing where you have a list resource, which is sort of the top level of it, and doing, like, for example, a get on that will return all of them or a paginated list. You can then post to create one. And it gets a lot simpler when you are going multiple layers down. You don't have to add more parameters to increasingly long functions. You just tack things on the end of the URI, just like sub-resources. And so on and so forth. And some companies might have things that go pretty deep, so it makes a lot of sense there. Now on to REST. This might be a bit controversial, but oh well. REST, or representational state transfer, is mainly the most common way of doing it, I would say doing it properly. It more or less maps state transforms to HTTP methods. So, for example, get fetches, put replaces or creates, patch updates, and delete removes. There is one small thing that the RFC 7231, which was released, I think, in April this year, which did change, is that post now does whatever you want it to. This was changed to fit reality, where everyone just did post was everything, which is a tad unfortunate. But so if you're wondering what you should use with it, just be pragmatic. If it makes sense to use post, do it. If it makes sense to use put, do it. It's fine. But just in case, document it anyway. You don't want to post and try and figure out what happens. If you document it very clearly, then there's no surprise because you can just point at it and say, this is what it does. Speaking of documentation, you should document the side effects of your API. If you do one thing and that spins off, for example, if you create a new record and that spins off some background job, you should make it very clear that that's what happens. You don't want to accidentally add something and have all of your things go down because it takes down all your EC2s to add another thing or all of that sort of thing. This is quite common sense, but I thought I'd mention it anyway. And don't be afraid of copying documentation styles which are good. For example, Stripe's docs are something that I like a lot. They have runnable examples on the side. They explain what everything means. They do quite a good job of it. So if you're writing API docs, do it like this. Mailgun also does it in a slightly similar way. They explain it all, and then they just have the examples in their own section. Meanwhile, companies such as Linode, this is the complete documentation for creating a domain in their DNS system. And up until I mentioned it to them, they even had things in there which were private and you're not actually supposed to send. And they don't have examples, they don't show you how to do it except on the main page, and then you've got to extrapolate it. And all of the responses are sort of mixed in with all of their other products, so you can get, or you won't get them, but your libraries sort of have to know that there's also the other stuff going on. And it's just overall very sparse. A lot of it doesn't make sense. For example, expiresec. What does that even mean? You can sort of extrapolate it if you know DNS, but if you're writing against DNS, it doesn't make a lot of sense. So you sort of need to explain it even though it might be a given. So even when I was implementing this myself, I had to actually go and look up some of the things because I was new to DNS and this did not help. So please don't have your API docs like that. Please. Validation is also a very important thing. It's great. It makes sure that you don't accept bad data so that you don't have to have if statements or cleaning statements further down your stack. You make sure that everything that comes in is proper and as it should be. It also makes users or implementers know that they can't just send random stuff at your API and have it accepted. So it sort of makes them implement the libraries properly, rather than it causing problems down the line because you accepted things a bit too liberally. You should also validate your outputs, because if you don't validate your outputs, you are possibly becoming part of the problem. There is also something, for example, with Heartbleed, how because there was nothing that was checking how much it was returning, there was no validation. If you have that on an API level, if you accidentally, for example, print a string representation of a user object which has their hashed password for some reason, it'll get rejected. You can use typed fields in Django REST framework for your import, for example. So a lot of frameworks will handle this for you. Otherwise, you can use something called JSON schema, which is framework agnostic, and you just get a blob of JSON and you validate it, and it can tell you what went wrong. And you can do things like you can say it can accept only these certain values or this certain type or a range of values, and you can have nested schemas or lists. So it's very good. If you want to implement this sort of thing, if you can't get it in your framework, it might be best to just put it in front of your web servers and just have them validate everything that goes through. There's also some things that you can do when you're making your API that you can make it potentially faster without worrying about ops things like what hardware you're running it on, just more the higher level sort of things. There is a status code in HTTP version 1.1 which is called 100 continue. What happens is that when a client, they can, if they're going to send a large amount of data, they can send, I expect 100 continue before I will send the request body. So what they do is they send the headers, then the server returns 100 okay, 100 continue if everything's okay, and then it sends the request body. This means that if you're uploading, for example, a picture or something like that, that might be several megabytes. If they don't have an authorization token in the headers or anything like that, you can reject it straight away and not tie up bandwidth. Unfortunately, if you're using Whiskey, you can't use it, or Twisted. Twisted doesn't support it yet, but I'm looking into it. Unfortunately, the Whiskey, I believe the Whiskey PEP says that the server has to handle this for you. There is no way to get it to not do that. So that's a bit unfortunate, but it does exist, and potentially, if there's enough push for it, someone could probably work out a way to get it in there. If you also make sure that your workers have at least state as possible and use the database or some other external state as a single source of truth, you will theoretically get better scaling, because then you can have a whole bunch of servers that can respond to any request in any order, and it doesn't matter because they all just talk to other external things. So my research on this topic has been a couple of API frameworks which I've sort of hacked together myself to see what's possible. The first one was Haddock. It was a small, very, very kludgy API framework that was just testing my ideas. It revolved around versions. You have a version and then you have endpoints under that version. There is no opting out. I then rewrote that on top of Twisted Web, just raw Twisted Web resources, so it actually is a lot cleaner. And it has things like JSON schema integrated, and I'm working on the HMAC authentication, which is in 1 or 2 RFCs, and the 100 continue, which I'm going to work on, and seeing if it is actually feasible to put this in something which developers can then use. So you can find it at that URL. The docs are a little bit spotty at the minute, and it's very proof of concept-y, but it does work somewhat. So through this, I've realized what our tools can do better for us, since better tools let us do more things for the same effort. So it's like a force multiplier. And rather than having to do it ourselves, our framework should do versioning for us. The good news is that who uses Django REST framework? Cool. Well, you might know about the Kickstarter for Django REST Framework 3. There was a stretch goal which is integrated versioning in Django REST Framework, and that stretch goal has been met. So hopefully that'll bring that into Django REST Framework and we'll all be happier. Validation. Lots of things validate on input, but not output. So maybe this could be done in a middleware if you use Django, or I think Flask has it as well. Otherwise, you can put something in front of your server. Please do validate your input and output. It also gives you another benefit. If you have your validation there, you can also use that to output documentation automatically. Heroku do something like this. They have a tool, it's called PRMD, it's in Ruby, and they take their JSON schemas and their API layouts and their API sort of descriptions in their schemas, and then they output automatically formatted markdown docs. So if you document it as you go, you just do one thing and you've got your API reference right there. And that can be all the help when you're bootstrapping an API. There's a whole bunch of things I could fit inside the 20 minutes, which I wanted to talk. Testing is very specific to the framework, but I will just say untested code is broken code. Please test your API, test it a lot. RPC over REST is something that everyone does differently. Usually it's just posting to something or a post with a command in it or something like that, which I think REST isn't really meant for, and maybe if you're doing RPC, you should use an RPC thing, but it is convenient to be able to just do it. Authentication methods. HMAC and signature authentication is something that everyone should look into rather than just using basic auth, because it means that you can use the user's credentials without sending them over the wire. There is also using, for example, TLS client authentication, which is something someone's mentioned, where you actually just use public-private key authentication for your API, which, if you're wanting to be really secure, that might be the way you want to do. However, all of this does fit on a website, and I will be writing over this as I write my book. You can find it all there. It's a bit of a work in progress, but I'm getting to things as I get to them. And thanks for the talk, thanks for listening, thanks for the rather lot of people. I didn't expect that many. So question time. If you don't get a chance and you want to argue with me, I will be around at large.